So this is on the least common multiple. So just to get started, this is the definition of things. The least common multiple of two numbers a and b, which we write as LCM AB, is kind of what it says, right? It's the smallest number that is a multiple of both a and b. All right, so let's see some examples. Lost my notes here. So find LCM of let's see, 45 and say 18. Okay. So in one sense here, what we're going to do is we're just going to start writing multiples of that. So write multiples of each. So 45, right? So you'll do 45, 90, 135, right? There's some mental math is pretty helpful here. Maybe I'll do one more, which should be 270. So, and then if I do 18, 18 is going to be 1836, 54, 72, 90, and I'm going to stop there because I just noticed that boom, boom, I've got 90 in both cases, right? So that's 90. All right. This isn't too bad. However, as the numbers get bigger, boy, you might just not want to keep doing this. These weren't too bad to do, but that's because like I picked a multiple of 5 here, which is actually pretty straightforward to do, but they get a little bit ugly as well. So we can use, here's what we're going to do, is we're going to use the prime factorization to do this. Let's see, so 45, again, is 9 and 5, 9 is 3 and 3. So I'm going to say 45 is 3 squared times 5. 18 is 9 and 2, which is 3 and 3. Right, so 18 is 3 squared times 2. And I usually write the 2 first. Okay, so how do we do this now? The LCM of these two numbers is the following. What we need to do is we basically need to make sure that I've got a multiple of each one of those. And the way to think about that is just make sure that you're covering all of the bases in all of these things. So I've got a 2. I need a 2. There's no 2's there. There's 1 2 in 18, so I'm going to leave that. 3 squared is common to both, and let me just make sure it's there, right? And if one was 3 cubed and the other was 3 squared, you would put the 3 cubed in there. And lastly, multiply by 5. Right, and I'm just going to rearrange this. 2 times 5 is 10, and 9 is 90, which was what we got before. Okay. So let's do another example. Let's see. Let's find LCM of 90, LCM 72. What do I want? 520. Okay. So 8 and 9. I get that 520. I've got 10 and 52. 10 is 2 times 5. 52 is 4 times 13. So I get that. So 72 is 2 cubed times 3 squared. 520. Ooh, I have 2 cubed again, okay. Times 5 times 13. All right, so I want to write, I need a 2 cubed, it's in both. I need a 3 squared, it's in that one. I need a 5 and I need a 13. Okay. Now often you can just leave it like that. And I don't know, let's just go ahead and multiply out. I'm going to do 8 times 5, that's easy. Times 9 times 13, 360 times 13. Four, 6, 8, oh. You good. Okay. Good. All right. Now, there's this really nice little relationship between the GCF and LCM. All right. And basically, actually, before I erase this, I'll talk about that. So remember again, GCF of these two numbers, 72 and 520, right, is the thing that's common to both of them. 2 cubed, right? All right. And one thing to notice is here is if I have LCM, and I'm just going to do this example first, and I'm going to multiply the GCF of the two. Then I have 2 cubed times 3 squared times 5 times 13. That's the LCM. We just did that right there. I'm going to leave it in prime factor form. And the GCF is that. Okay. Well, all I'm going to do is I'm going to rearrange things. I've got 2 cubed times 3 squared is those two. And then I have 2 cubed times 5 times 13. Right? That is 72. And that is 520. Okay. Now that's not an accident. The lowest common multiple of two things times the greatest common factor is just the product of the two. And often what we do is we'll use this relationship. I'm just doing some algebra dividing both sides by GCF of AB to give me that. All right. And the reason why is usually the GCF is a little bit easier to find. One thing is that it's always smaller. It's smaller than A and B always. It's just the nature of it, right? It's greatest common factor. Factors are at most either A or B. So there's that. The other thing is, remember, there's Euclid's algorithm to find the greatest common factor. And so there's this sort of natural way of going through and finding a greatest common factor, which is actually easier. I mean, that's easier than even finding prime factorization like this. Okay, so let's say I have the greatest common factor. It came from from something else. So find, so I'm going to say the lowest common multiple of 360 and 15 if, what do I want? Yes. If, I'm sorry, 135. 35. If the GCF of 360 and 135 is known and is, sorry, 45. 45. Okay. So what we're going to do then is we're going to say we're going to use this formula here. $360 times 135 over 45. Okay, now one thing that we can do with this is I could do the multiplication first and then do a division. But instead, it's actually easier if I first reduce this. So remember that this is a factor of both 360 and 135. So I'm going to note, let's see, this may be a little, let's do 45 into 135. That looks pretty easy to do. And if you are careful, you can show it's exactly 3. Right. So that means that this is 3. So I do 360 times 3, which may be a little tough in your head, but it's not too bad, or you can do a little column algorithm to figure that out, to come up with that. So what do we got? Okay. So that's the lowest common multiple of two numbers. All right, so that wraps up this video on least common multiple.